Hi, hello friends. Welcome back to my channel. In this video, we shall revise or we shall learn about one of the important concept of physics, that is units and measurement. Physics is an exact science. So the most basic aspect of the study of physics is the measurement of physical quantity. It's because in order to establish and verify physical laws, we have to make observations and take the measurements. So, in this video, we shall learn about units, measurement of longer distance objects, shorter distance objects, fundamental units, derived units, and also few basic forces in nature. Important forces in nature. Before moving to the video, if you are new to the channel, please do subscribe and press the bell icon so that you will get the notifications of the videos we upload here, which will be useful for CET, Central TET exams, TET exams, and also for HSTR and Gpstr exams also. As we move into the concept of units and measurement, a fixed measurement chosen as standard measurement to measure a physical quantity is called unit. For example, you can take physical quantity like pressure, force, etc. So to measure this pressure, we use the unit called Pascal, right? So Pascal is the unit of pressure in general. To measure force, we use Newton. So Newton is the unit of force, we can call. So to measure a physical quantity, we use a fixed measurement. Fixed standard measurement is called unit, or unit is also said as a specified measure of a physical quantity, or we can also call unit as standard of comparison used in the measurement of physical quantity is known as unit. So these are the very basic points. And what is measurement? Measurement is the process of comparison of the given physical quantity with the known standard quantity of the same nature. So the standard quantity used to measure the given physical quantity is called the unit. The comparison of the given physical quantity with the known standard quantity is known as measurement. So to measure the physical quantity means to determine the number of times its standard unit is contained in that physical quantity. For example, we can take a force of 10 Newton is applied on an object. Here Newton is the unit, 10 is the quantity, and force is the physical quantity, right? So these are the very basic points which a science student must be aware of this. And this quantity, we call it as quantity numerical value also. We say this number, numerical value, right? Okay. Now, what is the purpose of having this standard unit? Standard units is necessary for the sake of accuracy. It must be accurate. In measurement, we cannot say more or less. Okay, it must be accurate. It must be convenient to measure. It should not be like, okay, today it was of so much, tomorrow it is of changed. No, convenience could not be measured. No, like that. It should be convenient to measure. It must be uniformity also. It must be the same. It must be equal justice to all. It must provide. So these are the main points why the standard unit is necessary. And a standard unit is chosen should have the following main characteristics. What are its? Consistency. It means it must be it should not be variable. It should be consistent. It must be invariable. Next, availability. A unit must be available. It should be reproducible, and it should be imperishability. Imperishable. It must have imperishability. It means permanent. And a unit must be convenient. Conveniency it must have. It must possess the characteristic of convenience, right? Or it must be acceptable also. Acceptability we can say. These are the main characteristics of a unit, standard unit. Okay. Next, as we move further to fundamental units. What are fundamental units? A unit used to measure the fundamental quantity is called as fundamental units or very basic unit, or we can also say that a fundamental unit, a basic unit is that which is independent of any other unit. It does not depend on anything. It must be independent of any other unit, or which can neither be changed nor be related to any other fundamental unit. It is separate, independent. So, examples of basic fundamental units are: length is measured in meter. Meter is the basic fundamental unit of length. Mass, kilogram, kg. We write like this symbol. Time, second. Temperature, Kelvin. Luminous intensity, candela. Electric current, ampere. Quantity of substance, mole. So, these are the basic or fundamental units: meter, kilogram, second, Kelvin, candela, ampere and mole. And these are the fundamental physical quantities we call. And you can observe this the symbols which we represent. If any unit is under the name of a scientist, the symbol must be of capital letter. Okay, ampere is under the name of a scientist, so symbol must be capital. If you write in full word, it should be of all small letters only. Even if it is under the name of a scientist also, you must write as small letters only. And as we move further to supplementary units, there are two supplementary units, basics. For plane angles, we use radian to measure. Radian is the unit. For solid angles, ceridian, right? So these are the supplementary units. On moving further to derived unit, the unit used to measure the derived quantity is called as derived unit, or we can also say the derived units. Derived units are those which depends on the fundamental units. Okay, derived units depends on the fundamental or basic units, or which can be expressed in terms of fundamental units. Combination of fundamental units are called as derived units. And for example, the unit of area, how do you measure area? Meter into meter, that gives us meter square. Meter square is the unit of area. So it is of multiplication of two fundamental units. It could be of same fundamental or it could be of different fundamental units, right? Next, the derived unit of density is kilogram per meter cube, that is kg per meter cube. See, combination of fundamental, this is a combination of two fundamental units. Next, the derived unit for acceleration, that is meter per second square. Meter per second square, or this can be, when you take to the numerator, we can write like this also, meter per second square. As we move further to systems of unit, so these units are mainly classified into four types. There are four main systems of units, namely CGS system, FPS system, MKS system and SI system. So let us check out what is this in detail. CGS system CGS stands for centimeter, gram and second. Okay, and FPS is foot, pound and second, whereas MKS is meter, kg, second, and SI system is system international. So this system, SI system, is accepted universally, and we continue with this SI system throughout the world. In 1960s only, the General Conference of the Weights and Measures recommended that in addition to the units of length, mass and time, the units of temperature, luminosity and all is added here, and for the convenience of all this usage of this units, they have chosen this SI system only as final, which is internationally accepted. Okay, let us now move to the measurement of longer distance objects. First, astronomical unit. 1 AU, that is astronomical unit, is the average distance of the sun from the earth and has the numerical value, that is 1 AU is equal to 1.496 into 10 to the power of 11 meter. Okay, so this AU, 1 AU astronomical unit is the average distance of the sun from the earth. So we can see in this image, you see from the sun, the distance, average distance of the earth is called as 1 AU. So this is the base to measure the distance between the Mars and the sun. So they measure again in AU only, astronomical unit. First they will calculate this with the distance of this earth, distance between the sun and the earth, then from there distance between the sun and the Mars. It is about 1.52 AU astronomical unit. As we move further, next is light years. Light year, 1 light year is the distance travelled by the light in vacuum in 1 year or for 1 year. So you can observe in this image, you see the distance travelled by the light for 1 year. So approximately if we calculate this light, how much it could travel is around 9.5 trillion kilometer. So 1 light year is equal to 9.46 into 10 to the power of 15 meter, which is approximately equal to 10 to the power of 16 meter is the value of 1 light year, the distance which travelled by the light for 1 year. What is the speed of light in vacuum? That is 3 into 10 to the power of 8 meter per second. If it travels in that such a speed, for 1 year how much it can travel? This is the speed, 10 to the power of 16 meter. Next, parallax second or parsec, PC we call. 1 parsec is the distance at which average radius of the Earth's orbits around the Sun would subtend an angle of 1 second, that is second of an arc. 1 parsec is equal to 3.08 into 10 to the power of 16 meter, or 1 parsec is equal to 3.26 light year. As we look into this image, here there is a sun and earth. We know earth revolves around the sun in an elliptical orbit, and if you take a reference star here and the angle subtended by the sun, this is the angle. When this angle is in 1 second, this distance is called as 1 parsec. So much. So this is about the longer distance objects. What are they? Light year and parsec. As we move into the measurement of shorter distance objects, to express the wavelength of light, size and separation of molecules, atoms or orbit of electrons, a small size unit is used called as angstrom. Like this, A dot angstrom is used. 1 angstrom is 1 by 10 to the power of 10 meter. So this when you take to the numerator, 10 to the power of minus 10 meter, or it can be compared to nanometer also. 1 nanometer is equal to 10 angstrom. As we look into further smaller units, the size of nucleus is expressed in smaller unit called Fermi. F. 1 Fermi is equal to 1 by 10 to the power of 15 meter, or you can write like this, 10 to the power of minus 15 meter is the value of 1 Fermi. We shall now move to the next concept, that is fundamental forces in nature. In our daily life, we come across many types of forces. For example, frictional forces, elastic forces, magnetic forces, muscular forces, etc. All these forces are included in 4 basic types of forces. There are 4 fundamental forces in nature that govern the diverse phenomenon of macroscopic and microscopic world. These are gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. Let us learn about these basic forces in nature in detail. First, gravitational force. The force of attraction existing between any two separated bodies due to their masses are called gravitational force. So, according to the statement, here we deal with masses of the two bodies and the distance, separated bodies. The distance between them is playing a major role in deriving this formula for this gravitational force. So, as we look into this picture, you consider two objects, object 1 and object 2. Let the mass of object 1 is m1 and the mass of object 2 is m2. The distance between them is d. And the force of object 1 is taken as F1 due to the object F2, and the force of the object F2 is taken as F2, it is due to the object F1. So, according to the universal law of gravitation, here this forces of attraction between these two masses is directly proportional to the product of their masses, that is m1 into m2, and this force is also proportional, that is inversely proportional to the square of the distance between them. That means F inversely proportional to 1 by d square. Distance between them is d, so it is proportional to d square. On combining these two equations, we get F proportional to m1 into m2 divided by d square. On removing this proportionality constant, we insert a constant g, that is universal gravitational constant. And on writing this equation like this, F force is equal to, which is equal to F1, which is equal to F2, is equal to g of m1 into m2 by d square. This is the expression for gravitational force between any two objects of mass m1 and m2, and the distance between them is d respectively, if you consider. Okay, and as we move further to look into the properties of gravitational forces, very important points. Gravitational forces are always attractive forces. The gravitational forces are never repulsive. Next, gravitational forces obey inverse square law. That is, they vary inversely as the square of the distance between the two bodies. When the distance between the two bodies increases, then their forces decreases, means they vary inversely. Next point, they are central forces. Gravitational forces are central forces. They act along the line joining the centers of two bodies, masses m1 and m2 if you consider at this point, and these forces act as at the center of the two bodies. Since they are central forces, they are conservative forces. Okay, next, gravitational forces acts for a long range forces. They operate up to very large distances. Okay, next, very important point, gravitational forces, these forces are the weakest forces in nature. Remember this point. Among these four fundamental forces, the weakest forces are gravitational forces. Next, the field particle of the gravitational force is graviton. The concept of exchange of the field particle between the two bodies, they will explain about how the two bodies mutually interact from a distance. Okay, and the gravitational force is responsible for holding the entire earth together. As we know, we revolve around the sun, earth revolve around the sun, and gravitational force for binding the sun and the planet, it plays an important role. And also gravitational force enables, or it binds the solar system, and also it binds the stars into the galaxies. Okay, so this is the importance of gravitational force. As we move further to the next type of forces, that is electromagnetic forces. What are electromagnetic forces? These forces include electrostatic force and magnetic forces. The forces between two stationary charges is electrostatic forces, while the force between two magnetic poles is magnetic forces, we know. And these forces are not independent phenomenon, means they related to one another. A moving charge produces a magnetic field, while a charged particle moving in a magnetic field experiences a force. Means thus the electric force and the magnetic force are two aspects of electromagnetic forces. And you can observe here the basic phenomenon of producing or to get the electromagnetic force. Here a coil is placed in between the two poles of a magnet, okay, north pole and south pole. The basic phenomenon, when this coil is made to rotate in between these two powerful magnets such a way that current is induced, means current is produced, okay. So this is an example of electromagnetic force. Let us learn about these concepts later. At present, just remember just an example how they are related, interrelated. And as we look into the properties of electromagnetic forces, this may be attractive force or repulsive forces. Electromagnetic forces can be attractive or repulsive forces, and they obey inverse square law. And these electromagnetic forces are central forces and hence they are conservative. Next point is they operate sufficiently large distances, okay, not very large distances but sufficiently large distances they operate. And these electromagnetic forces are 10 to the power of 36 times larger than the or stronger than the gravitational forces, remember. So next, as we look into the field particle of this electromagnetic forces are called as photon. Photon, the field particle of electromagnetic force is photon, which carries no charge and it has a zero mass, photon, okay. Next, this electromagnetic forces bind the electron to the nucleus to form atom, and it binds the atom together to form molecules and binds the molecule together to form matter. So all this matter whatever we see today, all the object contains matter, right? So this is because of electromagnetic forces. Next, on looking into the strong nuclear forces, these forces are of nuclear origin, means they are responsible for holding especially neutrons and protons together inside an atomic nucleus. So we know inside a nucleus there exists neutron and proton, and the strong nuclear forces binds them together, okay. As that of the previous case, when we check into the electromagnetic force binds the electron to the nucleus to form atom, but here the strong nuclear forces deals with that, it binds a neutron and proton inside the nucleus, remember, don't get confused, okay. So as we look into the definition for this strong nuclear forces, these forces are of nuclear region origin. They are responsible for holding neutrons and protons together inside the atomic nucleus, okay. So we can observe here in this image the image of a nucleus, here an image of an atom where electrons revolve around the nucleus. Here you can observe neutron and proton inside the nucleus. And so in this type of forces we can see in this image the nuclear forces are basically attractive forces. They exist between neutron and neutron. It could be of neutron and neutron. Between this neutron and neutron there could be force, or it could be between proton and proton, or it could be between neutron and a proton, okay. So it could be of any type of forces. They are basically attractive forces, but sometimes they are repulsive forces also, okay. So as we move into the properties of this strong nuclear forces, The nuclear forces are basically attractive forces, and they exist between, these forces exist between neutron and neutron, Nn. They exist between proton and proton, pp, and they exist between neutron and proton, one neutron and one proton inside the nucleus. And the important point is, strong nuclear forces does not obey inverse square law. Okay, and they are non-central force, and hence they are non-conservative force. And these strong nuclear forces are extremely short range forces, and they act over distances of order 10 to the power of minus 15 meter. The nuclear forces become repulsive at smaller distances, appreciably to smaller distance in this case. Okay, and as we move further, the important point to be noted here in case of strong nuclear forces are, nuclear forces are the strongest forces in nature. Okay, strongest forces in nature, they are the strongest forces, whereas gravitational forces are the weakest forces, nuclear forces are the strongest forces. And field particle of strong nuclear forces are called pi meson. Remember this also, field particle. Okay, and in this competitive exams we cannot expect the level of the question. Okay, sometime it could be very easy type of questions, it could be of little higher in level also, it could be of numerical. Okay, so we must be thorough of the concepts from basic. Okay, next, moving into the weak nuclear forces. These weak nuclear forces were discovered during the study of beta emission from the nuclei. During the beta emission from the nucleus, inside the nucleus, the neutron is converted into a proton, positive charge proton, an electron, and an antineutrino. Remember, this neutron is converted into proton, electron, and antineutrino. This antineutrino is a particle having no charge and almost has zero rest mass. Okay, we know about proton of positive charge and electron of negative charges, and they have some masses, but here in case of antineutrino it is of zero mass. So in this case of nuclear forces, that is weak nuclear forces, here a continuous variation in the energies of beta particle that emitted from the nucleus, that leads to the conclusion that an electron and an antineutrino interact with each other through the weak forces. Okay, sometimes these leptons are also interact with each other and with the meson and baryons through the weak forces. Okay, so here we can just conclude that weak forces are the forces which cause light elementary particles to interact with one another with a heavier particle. Okay, and as we look into the properties of this weak nuclear forces, during beta emission, a neutron inside the nucleus is converted into proton, an electron, and an antineutrino, and it is 10 to the power of 26 times stronger than the gravitational force. Okay, even though it is called as weak nuclear forces, but they are stronger than the gravitational forces. Next, the field particle of these weak nuclear forces are called as neutrino. Okay, remember this point. And on concluding about these basic forces, the relative magnitudes of gravitational force, weak forces, electromagnetic forces, and strong nuclear forces, they are in the ratio 1 is to 10 to the power of 26 is to 10 to the power of 36 is to 10 to the power of 39. So here this 1 is the weak force. Which are the weak force? Gravitational force. And 10 to the power of 39 force, that is strong nuclear force. In between this two comes weak nuclear force and electromagnetic forces. Okay, so here we have almost covered the important points from the basic concept, that is fundamental units and measurements. In the following classes, we shall continue with the concepts or syllabus which is given in the expected syllabus of HSTR exams for the following HSTR exams, and these concepts also will be useful for Gpstr exam and basic TET exams and central TET also. Okay, if you are not subscribed to our channel, kindly do subscribe and press the bell icon so that you will get the notifications of the videos we upload here, which will be useful for the following exams. Okay, so if you like this video, don't forget to give a thumbs up. In the following classes, I shall continue to take maths classes also, if possible few chemistry classes and biology classes based on your expectations. Okay, thank you for watching.